Hello, students. So, in collaboration with Rjee Tech and Tech Tutorials, we are bringing the series of video lectures for class 10. My name is Ritvik Bhattacharya, and today I am going to be your course instructor. Okay, so greetings from Tech Tutorials, and let's get started. So, today we'll be starting series connection from the chapter Current Electricity. Hope you will like this lecture. So what happens in a series connection is that all of the individual resistors are connected end to end. Okay, so all of the resistors must be connected end to end. That means one end of one resistor would be connected to the other end of the other resistor, such that the current flows in a single path. Okay, so current will be flowing in a single path. So what do you mean by that? We'll come to this later. Just a second. Now, suppose the individual resistors over here are R1 and R2. So this is one end of the resistor R1 and this is the other end of the resistor R2. Again, this is one end of resistor R2 and this is the other end of resistor R2. Okay, so how can we connect these to form a series connection? Okay, so come back to the definition. They must be connected end to end. Okay, so one end of resistor R1 must be connected to the other end of resistor R2. So suppose you can connect this end to this end, right? So the resulting connection would be what? The resulting connection would be this R1 R2, right? So also you can connect which part to which, one and to the other, right? So you can connect this to this and to this end, right? So what will be the resulting connection? The resulting connection would be same. That means this will be R1, this will be R2. So this will be also series by the definition. Okay, and suppose you want to connect suppose R2 to R1. Okay, so that also can be done. So suppose you want to connect this end of R2 to the other end of R1, that is this to this. So this will be also a series there is connection. That means this will be the resulting, that is R2 and this will be R1. So this will be also a series connection. So remember that the series connection occurs when the individual circuit element, that is the resistors, are connected end to end. Okay, now we come to the special property of series connection. So what happens in a series connection is that same current will flow through all the resistors. Okay, and the same current will be flowing through all the resistors. How is this happening? So let us see. So suppose I take a circuit element. Suppose I take a circuit that forms a series connection. So suppose this is R1 connected to the other end of resistor R2. So this will form a series connection, right, from the definition. So suppose a current I is passing through R1. Okay, so the current I when passed through R1 will come over here, right? So that means the same current I that passed through R1 again will pass through R2, right? So what happens is that in a series connection, the same current flows through all the resistors. That means the same current I is flowing through R1, both R1 and R2. Okay, so this is one of the special characteristic feature of a series connection using which we'll do numerical problems also. So this will build up the base of the numerical problems. Okay, so see that this current I, see this current I is flowing through a single path, right? This current I is just flowing through this. If I want to draw in this way, right? It's flowing through in this way only. Okay, so what happens is that the current is flowing in a single path, right? So this is the single path the current is flowing through. Okay, so now we want to find the equivalent resistance of a series connection. So suppose I have over here a circuit which is in series connection, as you have learned by now. So this is R1 and this is R2, and we want to find out the equivalent resistance of this series connection. So what is equivalent resistance? So if I want to replace this circuit by a single circuit that behaves, suppose I want to replace this circuit by a single circuit that behaves exactly like this circuit. Okay, so I need to replace the two resistors with the equivalent resistor. Okay, so the equivalent resistor will behave as the two resistors R1 and R2 combined. Okay, so the behavior of this circuit and this circuit would be same. Okay, so for calculating the equivalent resistance, see what will we do. So suppose the current I is flowing through this circuit. Okay, so suppose this current I is flowing, obviously we have learned that same current I will be flowing through this circuit element also, R2 also, right? So for R1, suppose the potential drop for R1 be V1. Okay, so how can you calculate the potential drop V1? V1 would be equal to what? By Ohm's law, we know that V equal to IR. So V1 would be equal to I into which resistance the current is flowing through? R1. So that means V1 equal to I R1. Right. And now suppose the potential drop of this element R2, this element R2 be V2. Okay, so how can we calculate V2? V2 can be calculated as what? The current I is flowing through the resistor R2, right? So that means V2 would be equal to I into R2, right? So what is the net potential drop? Net potential drop. Net potential drop would be V net, right? So as you have guessed, V net would be equal to V1 plus V2, the net potential drop. So V net is equal to how much? V1 plus V2. That means it will be equal to I times of R1 plus I times of R2, right? So V net, that is the net potential drop, would be equal to I times of R1 plus R2. Okay, and suppose for the equivalent resistance. Okay, so this was our equivalent resistance. So what did I tell you? That the equivalent resistance behave as the two resistances combined, okay, in the circuit. So if I current is flowing through R1 and R2, I current must be also flowing through R equivalent, right? Because it might behave, it has to behave the same way as R1 and R2, okay, combined. Okay, so R equivalent, so I current is flowing through R equivalent, so the net potential drop across this would be equal to how much? V equivalent. Very good. So V equivalent is equal to I times of, right, I into R. What resistor I is flowing? R equivalent, right? So this will be V equal to I times of R equivalent, right? Very good. So now what can we draw from here? So what did I tell you? Equivalent resistance would behave as the combined of R1 and R2. Okay, so if the behavior of R1 and R2 is that it produces a net potential drop across the circuit, that is I times of R1 and R2, same behavior must be shown by R equivalent. So the R equivalent would produce the same potential drop across this two ends of the resistor. So this will be V equivalent. Okay, so by the definition of equivalent resistance, V equivalent must be equal to how much? V net, right? So now is just put the formula. I times of R equivalent will be equal to I times of R1 plus R2. Okay, so that means what happens is that the R equivalent is equal to R1 plus R2. Okay, so now we'll generalize this formula. Suppose I have this resistor R1, R2. So what will be the equivalent resistance? Equivalent resistance, as you have guessed, just sum this up. Series connection, so just sum up. R1 plus R2. Okay, so suppose I have three circuit elements, that is R1, R2, and over here R3. See, is it a series connection? First of all, you have to check that. Okay, very important. See, one end of resistor R1 connected to the other end of resistor R2. One end of resistor R2 connected to the other end of resistor R3, right? So series connection. So what will be R equivalent? R1 plus R2, just sum of the elements, plus R3. Okay, very simple. Okay, so if I just generalize this, um, just a second. So if I just generalize this, so if I have R1, R2, R3, and dot, the last circuit element be Rn. So what will be the equivalent resistance? So R equivalent would be equal to R1 plus R2 plus R3 Rn. That means R equivalent, in fancy terms, you can write this as summation of Ri, where I belongs from what? I is belong. See, I would be first element would be equal to 1. So I would be equal to 1 from start. It is the starting point, I equal to 1. Ending point is n. So the last resistor of I would be equal to n. So I equal to n. So this will be the equivalent, generalized equivalent resistance for series connection. I hope you like this tutorial. It is very easy actually to find out the series connection and do the equivalent resistance calculation. So I'll meet you in the parallel connection. Thank you. So this brings us to the end of this video lecture. There is a quiz attached in the description. Okay, so you can take the quiz and see your progress in this particular concept of this particular chapter. The student who scores the highest marks will also get a prize from Tech Tutorials. Thank you.